Hello friends, welcome to our YouTube channel Making Maths Easy. As said in the last video, today in this video I will be going to teach you, or I will be going to prove some important formulas like intersection and union. In this video I will prove these two important formulae. A intersection A union B is equal to n of A plus n of B minus n of A intersection B, and A intersection B is equal to n of A plus n of B minus A union B. So we will prove with the help of the Venn diagrams. First we will draw the universal set. This is the universal set. Then we will draw two sets, set A, uh, set B. Okay, this is set A, this is set B, and we will name it. This is set A, this is set B, this is the universal set. Okay, uh, before going to the notation, this is A intersection B, this is A union B, but we have to prove it. We have not to write the notation. We have not going to write the notation. We have to just prove that notation, that this particular thing means this. So for that we will color the shaded portion, color this portion. We will take the first proof. A union B is equal to n of A plus n of B minus n of A intersection B. We will shade this area as we have to prove this. In order to shade this area, we will mark it by lines. Now the area has been shaded. After shading the area, we will uh, represent it is as a diagrammatic form. Take a new slide, don't save. Now we will take another universal set. Take subset A, this, subset B, this. Okay, and give the notation. This is A, this is B, and this is the universal set. Okay, and lines. Now we will combine these two sets. Okay, we will write this A and B as n of A n of A union B equal to n of A plus n of B. In this case, n of A union B is equal to n of A plus n of B. But what about intersection case? As explained earlier, what about the intersection case? When this particular A set intersects this B set. Now this particular A set when intersect the B set, I will show you. This is the universal set, set A intersecting set B. A set intersect B set. Okay, at this particular point, at this particular point. So this portion, this portion of the set A has taken by set B. Similarly, this portion of the set B has taken by set A. Okay, so there are two portions of set A and set B. So in order to represent this, we can write it as we will write it down n of A intersection B. So n of A intersection B, as we all know, is this small section. I will mark it with lines in order to understand. So this is n of A intersection B. So what is A intersection B? A intersection B is some part of A intersect some part of B, or some region of A has overlapped some region of B. So both the regions have been overlapped over here. Both the regions have been overlapped over here. So our proof becomes, this proof becomes minus n of A intersection B minus n of A intersection B. So A union B is equal to n of A plus n of B minus A intersection B in this case. Similarly in this case. But in case of the disjoint sets, where both the sets have no relationship with each other, but in the case of disjoint sets where both the sets have no relationship with each other, n of A union B is equal to n of A plus n of B. Okay, n of A union B is equal to n of A plus n of B. But in the case of two sets intersecting each other at a particular region, so this region will be get eliminated one time, only one time this region will get eliminated, represent. Similarly, if you consider this whole portion, eating this portion, taking this portion as a set A, and this as a set, this only this portion as a set B, this eaten portion. So set B and set A occupies with each other to form A union B. Okay, so this portion of the set B, this portion of set B has been taken. I will show you. Wait. This is the universal set, and I am drawing only the intersection part. This is the intersection part. So this particular portion has been taken by set A as well as set B. Oh, so if we consider that earlier circle as set A, I will draw a circle here. Wait, it is wrong. I will draw it here. So this particular portion is this. This has been taken by set A as well as set B, but forget about one set. Let us consider this as A and this as B. Huh? Okay, this only this as B, and the whole portion eating the B section as in A can be considered as A, and this eaten section, not eating section, eaten section can be considered as B. So this we will split it out. This portion we will split it, and we will see, and we will determine that this portion one time has been splitted or taken away from the two sets. Hence we are subtracting n of A intersection B. Okay, so how, as we prove that A union B equal to n of A plus n of B minus n of A intersection B. Similarly, we will prove n of A intersection B. For this, we have drawn this Venn diagram. This is set A, this is set B, and this is the region of intersection, and this is a universal set. So we have to prove that this equal to this complete set plus this complete set minus union of these two sets. We will prove practically. So for that, I will take a new file, don't save, and take a universal set. Take two sets. This is A, this is B. I will not write the notation. This is A set, this is B set. Uh, if A set is intersecting B set at a particular region, this particular region, so this particular region has been taken by B set. A set is intersecting B set at this particular region, so the particular region of A set has been taken by B set. Similarly, if B intersects A, that particular region has been taken by A. Okay, vice versa. Uh, but in this case, A and B both are in a point of intersection. Both are in a point of intersection. If both the sets are in a point of intersection, as I draw here, A is intersecting B, and this is the region of intersection. This region, similarly, consider this whole portion as A, and this cutted portion, not the whole portion, as B. Okay, so B has lost some part, or you can also consider this whole portion as B and this cutted portion as A. So A has lost some part. In the case of B, in the case of A, similarly, both the cases, either A or either B has lost some of its part of set. So we can shade by using this shaded lines. We can represent it by using a shaded lines. This is the representation. Now this what is A union B? A union B is n of A minus n of B minus n of A intersection B. Similarly, what is n of A intersection B? N of A intersection B will be n of A, the whole circle, n of B, the another set, n of A one set, n of B another set, and when intersecting, when both intersect, we will minus n of A. We will do one thing. N of A we will add with n of B minus the region of intersection. Region of intersection can be occur only one time. In this case, A intersecting is B becomes 1, B intersecting A becomes 2. So these both the regions have been intersected. So only one region we have to eliminate from this. So we have to find only one region. For this, n of A is this whole, n of B is this whole. So formula become equal to n of A plus n of B minus only one region of intersection gets eliminated in this case. Okay, so we have to find only one region of intersection. So n of A plus n of B minus n of A union B. What is A union B? Nice question. As I told previously, A union B is this whole thing. A, B as well as this intersection is A union B. So only this part we will get if we will do this simplification. N of A plus n of B minus n of A intersection B. Similarly, you can do it by mathematically. See, here we have find A union B equal to n of A plus n of B minus n of A intersection B. Take this n of A intersection B on left hand side, so it will become n of A intersection B on left hand side equal to n of A plus n of B minus n of A union B. Okay, hence we have proved both the expressions, intersection as well as union. So if you like my video, please share, subscribe and comment on my YouTube channel. Thank you for watching.